meter from the ground. Okay, let's do another one. With what speed must an object be projected vertically upward for it to reach a maximum height of 120 meters above the ground? We want an object to reach 120 meters above the ground. What should be the speed with which you need to project it upward? I want you to think about this problem. Can you write down some of the known data here? What do we know? Well, we know we are looking for V0, the initial velocity of projection. What else do we know? Anything that is projected up, you should know has an acceleration of negative g. That is negative 9.8 meters per second squared. We know its acceleration. What else do we know? Well, you know its displacement. You see, y equal to 120 meters. It is at the position y equal to 120 meters. So, we know the acceleration, we know the displacement, we know one more thing. What is that? When the object reaches the maximum height, its velocity becomes 0. Vf equal to 0. Alright? Well, okay. At the maximum height, the velocity of the ball equal to 0. Is that right? If you throw something up, its velocity decreases, the velocity becomes 0 at the maximum height. So, Vf equal to 0. And we need to find the V0. Can you tell me what equation you will use there? We don't have time here. Obviously, we are looking for an equation that does not contain time. Alright? We got Vf equal to 0. We are looking for V0. Look at the equation we are going to use. The third equation. Vf squared equal to V0 squared plus 2ay. Vf is 0. We need to find the V0. A we know equal to negative 9.8 and y we know is 120 meters. Alright, let's put all those values there. 0 equal to V0 squared plus 2a. A is replaced by negative 9.8. Y is replaced by 120. And that is 0 equal to V0 squared minus, multiply these numbers, that is 2,352. Or V0 squared equal to 2,352. Square root of that is 48.5 meters per second. In order that an object may reach a height of 120 meters, you need to project it up with a velocity of 48.5 meters per second. Now watch how we do these problems that become so simple when you know how to figure out the data and the equation that will help us to solve it. Okay? Practice this. Only practice will make you perfect in solving problems like this. Okay, another one. A stone is thrown vertically downward with an initial speed of 12.5 meters per second from a height of 65 meters above the ground. That means it is thrown from somewhere above the ground. So that is your y0. Y0 is 65 meters. When time equal to 0, the position of the ball is y equal to 65 meters. How far does the stone travel in 2 seconds? And what is the velocity when it hits the ground? Okay, can you help me pick the data? It's not very difficult. And a stone is thrown vertically down with an initial speed V0. Well, V0 equal to 12.4 meter per second from this position. Y0 is 65 meter. This is where it is going to be thrown from, and it is at a height of 65 meter. And initial velocity, now look at the negative sign. Why did I use the negative sign? Because it is downward. So V0 is negative 12.4 meter per second. It is directed downward. There, that is the initial velocity. And the acceleration is negative g, negative 9.8 meter per second squared. You see, you need to figure out these given data. Okay, we need to find the position. How far does the stone travel in 2 seconds? In other words, in 2 seconds it travels up to here. We need to figure out that distance. And for that, we will first find the position at t equal to 2 seconds. Where is the object at t equal to 2 seconds? We will use this equation. Y equal to y0 plus v0t plus 1/2 at squared. Do we know all these quantities? Yes, we know y0. There you are. We know v0. We know a. And we know t. So use all those values there. That will be 65 plus. V0 is negative 12.4 times 2 plus 1/2. A is negative g, negative 9.8 times 2 squared. Do that calculation on your own. Alright, always check my calculation because I sometimes make mistakes, or maybe very, very often. So don't leave any calculation to me. Always do it on your own and check it. That will be 65 minus 24.8 minus 19.6. That is 20.6 meter. In other words, at the end of 2 seconds, the object is at y equal to 20.6. So it is here. This is 20.6 meter. Don't confuse it. This 20.6 is not the distance it has fallen. At the end of 2 seconds, its position is y equal to 20.6 meter. This one. And that means the answer to the question is, how far does the stone travel? It traveled this far. That means the whole distance is 65, and at the end of 2 seconds it is at y equal to 20.6 meter. Therefore, the distance it travels during that 2 seconds is 65 meter minus 20.6 meter. That will be 44.4 meter. That's where, that is how far it drops in 2 seconds. Alright, the next one. What is the velocity when it hits the ground? Well, we know the initial velocity. We know the acceleration. We need to find the final velocity. We know the displacement. Do we know the displacement? Yes. It traveled from y0 equal to 65 to y equal to 0. Can you figure out an equation that can be used here to find the velocity at the end when it hits the ground? To find the velocity of impact, we use y equal to negative 65. Why do we use y equal to negative 65? Because the particle or the object or the stone now travels a distance y equal to negative 65. It is going downward. It covered a distance 65 meter downward. So we use y equal to negative 65. In the equation, vf squared equal to v0 squared plus 2ay. Well, we need to find the Vf. What's the velocity when it hits the ground? We know V0, we know A equal to negative 9.8 meter per second squared. Y equal to negative 65. Alright, that gives you Vf squared is V0 squared, negative 12.4 squared, plus 2 times, in place of A I wrote negative 9.8, in place of Y I wrote negative 65. And that, you can see negative, all this becomes positive. Vf squared is 1427.76, or Vf is square root of that, that is 37 meter per second downward. Okay, let's do